Okay, so I'm gonna leave this one there and go to this. So I'm looking at writing expressions in radical form. Um, we talked about this yesterday, so I'm gonna kind of go quick. Um, Fractional exponent. Fractional exponent. The numerator is like your power, and then the denominator is your radical. So this right here is the seventh root of 3mn to the fourth power. Now, I want to make sure that you understand the difference between this and this. Those are not the same thing. This fourth power is associated with all of that, the 3, the m, and the n. But in this instance, it's just associated with the n. Does everybody see what I'm talking about? Okay, you don't see what I'm talking about? Okay, so I need you to understand the difference, because when I gave a problem similar to this, people did this, and that was wrong. Okay, now in all honesty, I'm gonna do this over here just so you can see. You actually could have went like this. That is 81 m to the fourth n to the fourth. That's actually what the answer is, because 3 to the fourth isn't that big of a deal. And obviously m to the fourth and n to the fourth. I'm Because 3 to the fourth is 81. 3 times 3 times 3 times 3. It's the same as 9 times 9. So, I'm old math teacher, so I know 3 to the fourth is 81. So what I'm going to say is either one of these would be acceptable. Okay? This one is not, because it's wrong. And I need you to understand that. That one right there is wrong. That is wrong. Either one of these is acceptable. Now, that being said, I might talk to Tipton and see if maybe we'll give an extra, maybe a half a point or something extra credit if you do this as opposed to that. But the bottom line is neither one of these are wrong. Either one of them is acceptable. But I need you to understand that this one is not. Does anybody have any questions on what I'm talking about? What you got, Joey? Oh, that's thumbs up. Okay. No questions? All right. All right. So like this one. This one right here, that's the ninth root of 7ab to the fourth, all taken to the second power, which ends up simplifying to the ninth root of 49 a squared b to the eighth. Either one of those answers are acceptable. All right. I'll leave the last one for you. So now let's talk about this. But before I talk about this, let's talk about this. I skipped this. What? Hold on, what? Okay. I skipped this because even though this is the same, it's the same stuff, it's just in a different format. And this is how it's going to look on the test. So I just say, you know what, let me just focus on this. If you want some extra practice, feel free to mess with that. If you want me to work that stuff out later, no problem. But it's the same stuff. No, of course. So anyway, I got told that this was a lot, so I'm gonna try to go through it slowly, but I need you to pay attention. So what we're doing with this is we're doing the log product rule, the log quotient rule, and the log power rule. Okay, we're using all three of those. So I'm gonna start by using the product rule. I got 2, 3, 5, and 7. So that's my clue that I need to change these to to um to multiples of 2 or multiples of 3. So 36 is 4 times 9. So 36 is 4 times 9. So now the product rule says I can change that to the log of 4 plus the log of 9. That's the product rule. Right? Well, again, I've got 2 and 3. So I look at the numbers that I got. I'm like, you know what? I'm going to make this log of 2 to the second power, and I'm going to make this log of 3 to the second power. Now I'm looking at in multiples of 2 and 3. So that was, first I used the product rule, then I just changed them using exponents, and now I'm going to use the power rule. The power rule says if I have a log of some number or some whatever to a power, I put that power up front. Hey, what's up? Mm-hmm. Oops. Yeah, no problem. Thank you. Yep. All right. So that's 3. Sorry. Yep. Okay. So what do I got here? The power rule says I can take this and change it to 2 times the log of 2 plus 2 times the log of 3. All right. And now I'm just doing substitution. I got 2 times the log of 2, which is 0.3010, plus 2 times the log of 3, which is 0.4771. Yes, sir. That's exactly what you got to do. Well, I think on the test I gave you 1 through 9, I think, but I'm just going by the example that I got here. So anyway, oh, bottom line is you're not getting a calculator for this. So I'm expecting you to know how to multiply 2 times that. Now I'm also so what's that? 0, 2, 0, 6, and this is what 2, 4 carry the 1, 5 carry the 1, 8, 9. Hey man, Mr. Ferguson's wrong. Yeah, yeah, no, fair enough. All right, okay. Okay. So anyway, so now I've got 2 decimals that I need to add together. I'm also expecting to know how to add decimals. So what's that? 2, 6, 5, 1.5. So that's my answer. Yep, I added those 2 together. So I'm expecting you to know how to do that. Yep. Okay. Do the next one over here because I ran out of room. That's 1.5562. Yes, sir. Right here. That's the final answer. So now I got the log of 1035. So 10 over 35. That's a division problem, right? And division means I got a quotient, so I use the quotient rule. The quotient rule says I can make that the log of 10 minus the log of 35. Well, I look at my chart. I don't got 10 or 35, but I do got 2, 5, and 7. So I'm going to change this to the log of 2 times 5 minus the log of 5 times 7. So now I'm going to use the product rule. So right here, I'm going to have log of 2 plus log of 5 minus, now this is minus both of these. So I'm going to add a log of 5 plus the log of 7. That's the quotient rule. Then I just did some simple factoring. I broke down 10 to 2 times 5. I wrote down 35 to 3 times, excuse me, 5 times 7. And then I used the product rule. 2 times 5, that's the log of 2 plus the log of 5. And 5 times 7, that's the log of 5 plus the log of 7. All right. So, what? Oh, so next, now I'm just going to replace. So the log of 2, so that's 0.3010 plus the log of 5, that's 0.6990 minus, now this is minus both of these, so I add them together, then subtract. So 5 is 0.6990 plus 0.8451. All right. So when I add these first 2 together, I just get 1. It's just 1 or 1.0, however you want to say it. And then when I add those 2 together, What do I get? Let's see. 1, that's 14, carry the 1. That's another 14, carry the 1. That's 1.5441. And so now I've got 1 minus this. The second number is bigger. It's a subtraction problem, so I know I'm going to end up with a negative number. So that's just negative 0.5441. And that's my answer. One point 1.5441 subtraction problem, so I swapped it and just subtracted. So again, no calculator. You should know how to do decimal math. It's a lot of steps. I admit there's only maybe one or two, so don't sweat it too much. Does anybody have any questions? I wait another minute, but I'm putting it on. I'm putting it on my YouTube thing. So if I'm going a little too fast, you can always look over it again. All right. If I'm moving to where you didn't get to write something down, it'll be there. Okay. Say it again, sir. Okay. So next, I got these two things for scientific notation. I put a whole bunch of stuff there because honestly I was lazy and I just cut it out the book. You don't got to do all these. There's maybe 2 or 3 of them on there. Okay, so it's not like it's gonna be a whole bunch. I just wanted to give you some practice problems and all this extra stuff that folks got worried about. That don't matter. That's just extra unit stuff. All I'm concerned about is the numbers and getting them from standard form to scientific notation or from scientific notation to standard form. So like this first one, 0. What is that? 1231785. I want to get it in scientific notation. So I'm gonna move my decimal to the first non-zero number. Uno, dos, tres, cuatro. So 4 moves. That's 1.785. I did 4 moves, so times 10 to the negative 4. Right? If I've got I'll just do this. 186,000, right? Now I'm going to go the other way. So I'm right here. 1, 2, 3, 4, 5. That's 5 moves. So I got 1.86. Now the zeros before my non-zero numbers, they're called insignificant. All right. So I don't worry about those zeros right there. All right. So I'm gonna have 1.86 times how many moves did I make? 5. So that's fifth. Now, if my number starts off bigger than 1, then my exponent is going to be positive. If my number starts off smaller than 1, then my exponent is going to be negative. So point or 0 point is the clue to, oh, I'm going to have a negative exponent when I do scientific notation. And, 7 comma tells me I'm going to have a number that's positive for my exponent. Okay. Just the last one, G. What is that? 7046 0000000. Now, this is what I was talking about as far as significant and insignificant. These zeros on the end, they don't matter, they placeholders. That 0 matters because it's between my numbers. Okay? So that 0 is going to get included in what I'm doing. The other zeros are not. So because it's bigger than 1, starting on the far right, count my moves. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 moves. So that's 7.046. That's why I want to make sure you understand. That 0 matters. The other zeros don't. Times how many moves did I make? 9. Boom, done. All right? And then the same thing going the other way. 9.46 times 10 to the 15th. That's a positive number, so my number should end up bigger than 1. So I got 9 4, 6, and then I just start counting my moves. I've got two numbers from here. And so how many more moves do I got to make with zeros? If I move this decimal, I got 13 more zeros to add. There you go. All right. Right here, 1.354 times 10 to the ninth. Well, I got three numbers first that I move my decimal in. How many more zeros do I need to add? Six. 1, 2, 3, 4, 5, 6. Right here, 1.429 times 10 to the negative 4. Negative. Negative exponent means I'm going to end up with a 0 point. So that means I'm moving this way. So I've got my 429. I got my 1. That was my first move. How many more moves do I got to make? 3. So 1, 2, 3. Put a 0 in front. The 0 in front don't count. Right here, 7.8 times 10 to the negative 2. So I got 7 and 8. I made one move. So how many more moves do I got to make? Right here, how many more moves? Just one. Put a 0, and then I add a 0 in front. That's it. Anybody got any questions on these? Like I said, it's straight out the book. There's only going to be a couple on there, so it's not like it's going to be this many. Maybe two or three. All right. So let's talk about this. All right. Let's see. How about green? Okay. Sine. I've got a triangle, and I want to talk about sine of 60 degrees. So sine as a ratio is the opposite side length divided by the hypotenuse side length. Hypotenuse. Definitely not a spelling teacher. All right. So now I just put the side lengths in there. The opposite side from that 60-degree angle is the square root of 3 over 2. And then the hypotenuse is the opposite side from my right angle. So that's 1. And anything over 1 is just that thing. So it's the square root of 3 over 2. Cosine. Cosine is the adjacent side. Adjacent. I hope that's spelled right. Over the hypotenuse. So the hypotenuse is 1. The adjacent side from my 60-degree angle. Adjacent means next to. Obviously, opposite means on the other side. So that's 1/2. So I got 1/2 divided by 1, so that's just 1/2. So I got 1/2, and I got the square root of 3 over 2. Now, tangent is sine over cosine. So what I'm going to do is I'm going to find the sine of 30 degrees and divide it by the cosine of 30 degrees. So let's erase all this stuff and look at that. So I'm looking at 30 degrees. So I'm right here. Come on. All right, so right here, 30 degrees. Sine is opposite over hypotenuse. So that's 1/2. Cosine. Cosine is the adjacent. So that's square root of 3 over 2. Now I'm skipping this because it's 1. It's the square root of 3 over 2. So what kind of problem is this now? It's a keep change flip. I got a fraction divided by a fraction. So that's 1/2 divided by square root of 3 over 2. So keep change flip. 1/2 times 2 over the square root of 3. The 2's cancel off, and I got 1 over the square root of 3. But 1 over the square root of 3 isn't what you're supposed to end up with, right? So you got to rationalize. I multiply both the top and the bottom by the square root of 3, and I get the square root of 3 over 3. Now, in all honesty, I'm going to let this go. If you give me that answer, I'm going to call it a day. I'm going to check and see if you go the extra step. Maybe I'll give you a half point extra credit. So I need to check on that. But I'm telling you right now, either one of those answers is acceptable. Okay? Don't know about the extra credit, but I do know that either one of those answers are fine. Anybody? For both of us. So does anybody have any questions? Now, I'm not holding you up. You need to do that. That is math. That is simple math. But I'm saying that for all intents and purposes, I'd accept that answer. Okay? All right. How did I figure out the sine and cosine? You mean here, here, or here? See? Okay. I went sine of 30. So I looked at from the 30 degrees. I just remember opposite side hypotenuse. So I went opposite hypotenuse. 1/2 divided by 1. And then right here, that's why I wrote this first. Adjacent side hypotenuse. So that's 30. Adjacent side is square root of 3 over 2 over 1. Yep. So that's something for your note card. All right. Yesterday, I jumped to this, so I'm going to jump to the unit circle, and then we'll go back. All right, so let's talk about this. Say it again, sir. Stop doing what? I was jumping to something. I was jumping to something that was similar because it's similar. I thought that would be easier for you to understand. So anyway, the unit circle is going to be on there. It's going to look something just like this. So the unit circle's on there. What you need to understand is that this diagram says the cosine is my first coordinate, the sine is my second coordinate. So you also need to recognize these the radians, the measure of the angles in radians. So sine of pi over 3 is the same as sine of 60 degrees. So that's right here. Sine is the second coordinate. So that means this one is the square root of 3 over 2. Done. Yes. Yes. Because because last semester we were doing changing degrees to radians and radians to degrees. That's why I'm not doing this now. That's why we didn't put a problem on there changing it. I'm just saying, see, it's 60 and it's pi over 3. So that's not something you need to be worried about. Now I got 5 pi over 6. 5 pi over 6 is right here. Well, that's why I'm showing you up here, Joey. It's right here. Okay, so I'm looking for cosine. Cosine is the first one. I need you to notice that this right here says negative square root of 3 over 2. Negative square root of 3 over 2. Can everybody see that that's negative? All right. I'm old and I can see it, so y'all should be all right. All right. Next, I've got tangent of 3 pi over 4. Where's 3 pi over 4? 3 pi over 4 is right here. All right. So now remember what tangent is. Tangent is sine over cosine. So that means I need to take the sine and divide it by the cosine. Well, the way this is set up, sine is the second coordinate, cosine is the first coordinate. So that is the square root of 2 over 2 divided by negative square root of 2 over 2. Yes. Yep. That's is just like this, ma'am. That right here. So unit circle cosine of theta, sine of theta. Okay. And so the square root of 2 over the negative square root of 2 is the same as saying 5 divided by negative 5. The 5s are the same, whoop-de-doo, but the negative, so that becomes negative 1. All right, last thing. I put this on there. I was trying to decide whether it was going to give you extra credit or not. There's cosecant and secant. Cosecant equals 1 over sine. Secant equals 1 over cosine. So then what you'd have to do is you take, like if I said, what's the cosecant of pi over 6? So I go to pi over 6, it's right here. Cosecant is 1 over sine. So I say 1 over, and then what's the sine? The sine is 1/2. So what kind of problem is that? Keep, change, flip. Yep. Keep, change, flip is excellent. So 1 divided by 1/2. That's 1 times 2 over 1. So the answer to that one is 2. So again, on your note card, you might want to have this stuff right there. All right. And then maybe we'll throw one on there for extra credit. Does anybody got any questions about the unit circle? All right, now we can go back to the log stuff. So we got three different things. We got solve for x, we got condense, and we got expand. Condense and expand are talking about the product rule and the quotient rule. Well, I guess you could say the power rule too, but it's mostly the product rule and the quotient rule. Before we get to that, we're going to just do the condensing. So solve for x. Okay, yes. It is 6 squared equals x. I changed the log to an exponential form. Yeah, but you're right, bro. You're right. You're not wrong. I'm just taking it through the steps. So remember, my base and my answer, that's my exponent. So 6 to the second power equals x. So the x equals 36. Right here, changing it to exponential form, that's 5 to the third power equals x. 5 to the third power, so x equals 125. Right here, that's 16 to the negative 1 power equals x. So what does x equal? 1 over 16. The negative 1 exponent or the negative 1 power just means take the reciprocal. And if it's that is what x is, bro. I'm showing you steps that you can use to solve it, but I mean you solve it however you want to. So it's not like I'm looking for work on this. If you don't put that and you just put x is 1 over 16, it's not like it's going to be wrong. So right here, I've got, what is that, log of 9? Thank you, sir. So that's 9 to the second power. Thank you. 9 to the second power equals x. So that's going to be x equals 81. Then what about 23? I'm going to have 1 over 4 to the negative second power equals x. So what does x equal? Now 1 over 2. So I got 1 over 4. The negative exponent says I need to take the reciprocal. So now it's 4. And so now I got 4 to the second power. 16. Excuse me. The 2 don't care about the negative. The negative only makes you take the reciprocal. So I took the reciprocal of 1 over 4. That's 4 over 1. And then I took it to the second power, 16. What about this one? This is x to the third power equals 64. What does x equal? 4. And then last but not least, this is x to the negative 1 equals 8. What does x equal? Nope. Nope. 1 over 8. Negative exponent means I need to take the reciprocal. If I end up with 8, I need to take the reciprocal of that to see what I started from. Oh, man. Yeah. That's why I said, oh, man, because oh, man. And that power strip wasn't on and I didn't even know. Okay. So sorry about that. It was dark. I didn't even realize it. So anyway, this is 1 over 8. So anybody got any questions on this? Okay. Condense. So I got an expanded log. I want to make it to where log only appears once. So like right here for 37, I got log, a log, and log. I want log once. So this one right here is the quotient rule, right? Because it's a minus. So this is going to be the log base 3 of 7 divided by x. I didn't put the parentheses just to be on the safe side. That's the product quotient rule. The plus tells me I got the product rule. A number in front tells me I got the power rule. So the first thing I'm going to do is change this to log base 5 of x to the second power plus log base 5 of 3. Then I'm going to change this to log base 5 of 3 times x squared. Everybody follow me with what I did? I went to power rule, then I went to quotient, the product rule, excuse me. Plus means product, minus means quotient. So right here, I got three of them. So that's just three things being multiplied because of the pluses. So that's log base 4 of 5xy. Like I said, put the parentheses just to be on the safe side. All right, right here. I got a number on the outside, so that's the power rule. So that's log base 10 of x to the third minus log base 10 of 4. The minus tells me I'm doing the quotient. So that's going to be log base 10 of x to the third divided by 4. Right here, I got a number. I got two numbers up front, so that tells me I'm going to use the power rule. So I'm going to have log base 2 of x to the second power minus log base 2 of y to the third power. That's the first step. The next step is I got a minus, so I'm gonna do a quotient. I'm gonna have a division problem. So log base 2 of x squared divided by y cubed. And then the last one I'm gonna leave for you. Anybody got any questions? I'm holding. Anybody got any questions? Like I said, I'm recording this, so you can go back and look at it if I'm moving too fast. I mean, if you didn't get a chance to write it all down. Questions? Yes, no? All right. Expand. Now I'm doing the same. I'm using the same stuff. Product rule, quotient rule, power rule. So right here, this is going to be log, what is that, base 6 of 3 plus log base 6 of x. All I did was say I got 3 times x, so the product rule says I can separate them. Right here, this is x divided by 5. That's the quotient rule. So I'm going to have log base 2 of x minus log base 2 of 5. Right here, I got a power rule, so I need to be careful. So first thing, I'm going to separate them. That's being multiplied. So that's log base 10 of x plus log base 10 of y to the second power. Then I'm going to finish it up by saying it's log base 10 of x plus 2 times log base 10 of y. And that's my answer. First I did the product rule, then I did the power rule. I just work here, man. All right. It's what page did I say yesterday? 86. 86, all the rules are on that page in your book. Um but I'm gonna make a video for your note card, so that should go on there. So next, this is a quotient and a product. I got a product here, but then I got a quotient too. So I'm gonna separate it. First thing I'm gonna do is say, whoop, sorry. I'm gonna say log base 4 of x times y minus log base 4 of 3. So that's the quotient rule. I got the stuff on top, my numerator, stuff on bottom, my denominator. And then this is the product rule. So I'm going to separate that. Log base 4 of x plus log base 4 of y minus log base 4 of 3. And that's my final answer. It's just taking this, expanding it, using the product rule, the quotient rule, or the power rule, and expanding it. So this one right here, there's three things being multiplied. So I know I'm gonna expand it. I'm gonna have three of them. Then I got a power that I do at the end. So this is gonna be log base 3 of x squared plus log base 3 of y plus log base 3 of z. And then last, I've got a power, so I'm gonna say 2 times the log base 3 of x plus log base 3 of y plus log base 3 of z. Okay, just so we're clear, I'm recording this. I'd appreciate if you wasn't talking about my girl on my recording. Yes, they can. Yes, they can. No. So anyway, last one is the product rule. I'll leave it to you. Plus. Let's see. That's all of that. Okay. Yep. All right. So let's talk about this. We're talking about operations with compound numbers. So I got two compound numbers that I'm adding together. So I just add like terms. So I got the real number part, and then I've got the imaginary part. So negative 9i plus 14i is 5i. And then I've got 10 plus a negative 3, that's 7. And so that's my answer. Now, getting it in a plus bi form, if a is 0, then you're just going to have the imaginary number. Or if b is 0, you're just going to have the real number. So right here, you need to do FOIL. FOIL or the box method. I don't know which one you guys use. So yes. So 7 times 4, that's 28. That's the first term times the first term. And then you got, the outer terms. The outer terms that you multiply. So that's 7 times 7i. That's 49i. Then you got the inner terms. That's 4i times 4. That's 16i. And then you got the last terms. That's 4i times 7i. That is 28i squared. So 28 plus 49i plus 16i plus 28i squared. So first thing I do is combine the i's. So that's 28. Yes, 28. Yeah, because I have 4i times 7i. So, yep, two i's. So the I, you just treat it like a variable, when you're multiplying or stuff. So anyway, 28, that's what, 65i plus 28i squared. What's I squared? What is I squared? I squared is negative 1. Yep. I equals the square root of negative 1. So I squared equals negative 1. That's the whole point that they use I for. So you can have negatives under your radical. So that's going to be 28 plus 65i plus 28 times a negative 1. So that's going to be 28 plus 65i minus 28. The 28s cancel each other out, so I'm left with 65i. That's my answer. I times I, yep, I squared is negative 1. I is just the square root of negative 1, excuse me. And this last one, I'm just multiplying, just doing a distributive property. Negative 5 times negative 6, that's positive 30. Negative 5 times 11i is negative 55i. That's it. Right. All right. This right here, we're gonna do something a little different. I want to see if y'all recognize this. Yep, y'all be all right. All right, right here. That is a Okay. What do I need to stop? What's up? Okay. Do I need to go back? I can. You sure? Well, I mean, you say I was going too fast. I mean, I'll slow down. Okay. So anyway, this right here is a system of equations. We did this before. Anybody remember the method that we had to use to solve this system of equations? Say it again. No. Take your time. Nope, but you on the right track. Substitution. I need to do substitution. So I'm going to take this second equation and make it y equals 12 minus x. And so then in my first equation, I'm going to replace 12 minus x, or replace y with 12 minus x. So I'm going to have x squared plus 12 minus x squared equals 144. Yes, I'm waiting. No problem. That's the substitution method with no, I was stopping. We haven't got to the answer yet. Let me know when I can continue. Okay. So I need to do FOIL, or I need to multiply that, because this right here is 12 minus x times 12 minus x. So that's going to be x squared plus 12 times 12 is 144. 12 times a negative x is negative 12x. And then negative x times 12 is another negative 12x. And then negative x times negative x is x squared. Oh, shoot, I ran out. Say that again. And so now I combine like terms. I got I got two things right here, and I got two things right here. So I got x squared and x squared, that's 2x squared. I've got negative 12x and negative 12x, that's negative 24x plus 144 equals 144. I added like terms, man. So I got negative 12x and negative 12x. I combined it to be negative 24x. I got x squared and x squared. I combined it to be 2x squared. What don't you get? All right. All right. Let me finish this problem, and then I'll do you one better. Okay. Let me finish this, and then you'll understand. So anyway, next thing, I'm trying to get x by itself because I want to figure out what x equals. So I'm gonna subtract 144 from both sides, and I get 0. So now I got 2x squared minus 24x equals 0. Then I factor, and so I pull out 2x. So I'm gonna have x minus, what is that, 12 equals 0. And then I need to solve that. So that's gonna be x equals 0 and x equals 12. Okay, it's fine. It's not. Forget it. Yep, there. Forget it. So here's what we got. You need to be able to recognize an equation and pull out the center of the circle and the radius. Okay, I was going to try to put that on there. I'm not. So anyway, what's the center of this circle? What is it? Then tell me what it is. The format for the equation of a circle is x minus h squared plus y minus k squared equals r squared. R is the radius, h and k are the center of my circle. So if I look at this, there is no h and k. That means there's 0. So the center of my circle is 0, 0. If my equation says r squared is that number, then what's r? What's r? 12. I take the square root of that number. So that's what you need to do. So then right here, what's my radius? My radius is 5. What's my center of my circle? 3, 4. Might as well wait. You might as well wait. So what's the center of my circle here? 12 and negative 5. Because the format says x minus h and y minus k. So you're looking for it to be negative. So then what's the radius? What's the radius? 169. You're all right. No sweat. What is it? It's 13. Last one. What's the radius? It's not a whole number. Yes, what is the radius? Give me 1 second. What's the radius? It's just square root of 38. Don't make it harder than it is. If it's not a perfect square, you can just put the square root of whatever, and that's it. And then what's the center? 0 and 8. Say it again, ma'am. Okay, hold on.